Okay, so we're going to have a look at question 2 from the 2013 Leaving Cert Ordinary Level Paper 1. It was a question about functions and graphs, though there is an area aspect of the question in the B part where we're asked to use the trapezoidal rule to estimate the area under this curve. So we're told that the diagram shows the graph of the curve f of x equals 6x minus x squared. So this is a quadratic function. It has a minus x squared, which explains the n shape of this curve. We're asked to find f of 0, f of 1, all the way up to f of 6. So what they're asking us for is the corresponding y values, or f of x values, for the x values from 0 to 6 in the domain. So we're going to individually find each x value from 0 to 6 on the diagram and see where it cuts the curve. So we can see here that when x is equal to 0, well, y is also equal to 0. So we fill in our table. When x is 0, f of x equals 0. So moving across to x equals to 1 and tracking up until we meet the curve, we can see that the y value, or the f of x value, will be 5. So we update our table, and when x is equal to 1, f of x equals 5. We move across to where x is equal to 2, and we go up the graph, and we can read that y value, or the f of x value, is equal to 8. So when x is 2, f of x is 8. We move across to 3 and all the way up to the top of the curve, and we can see that the y value, or the f of x value, is 9. We move across to 4 and then track up until we meet a point on the curve, which is again f of x, or y, is equal to 8. 5 will give us an f of x value of 5, and 6 will give us an f of x value of 0. And so our table is complete. So just be careful that f of x and y, those terms are interchangeable in terms of, we normally have an x-axis and a y-axis, x being the domain, or the inputs, and the y numbers being the outputs, or the range. Another way that we could have found these f of x values was to fill out a table, sub in the x values from 0 to 6 into our function one at a time, and get our outputs, our f of x values. So if we sub in 0 into the function, we get 6 by 0 minus 0 squared, which is 0. When we sub in x equal to 1, we get 6 by 1 minus 1 squared, which is 5. X equals 2, we get 6 by 2 minus 2 squared, which is 8. X equals 3, we get 6 by 3 minus 3 squared, which is 9. X equals 4, we get 6 by 4 minus 4 squared, which is 8. X equals 5, we get 6 by 5 minus 5 squared, which is 5. And then 6 by 6 minus 6 squared is equal to 0. So this just confirms that these are the points. And it's also good to look at this from the point of view of, the question could have been to draw the function f of x equals 6x minus x squared. And so this would have given us our points that we could have connected up to have this n-shaped quadratic function. The B part says to use the trapezoidal rule to estimate the area of the region enclosed between the curve and the x-axis in the given domain. So they're talking about the area all underneath this graph, all the way down until the x-axis. And the way the trapezoidal rule does that is, it imagines each of these intervals as being a trapezoid. And then the formula sums the 6 areas together to give us an estimation of what the area underneath that curve would be. A good way to remember this rule is to say that the area is equal to h over 2 on the first plus the last plus 2 times the rest, where h is the interval gap. So we can see in our diagram, h is 1 unit wide. Each of the intervals is 1 unit. The first height, well, there is actually no first height here. When x was 0, y is 0, which means that there is no height on the first. The last also has no height. When x is equal to 6, y was equal to 0, so there's no height on the last. And then 2 times the rest of the heights. And the rest of the heights were the values we found in part A. 5, 8, 9, 8, and 5. So we sub these into the formula, and the area will be estimated as 1 over 2, the first height, which is 0, plus the last height, which is 0, plus 2 times the sum of the rest of the heights, 5 plus 8 plus 9 plus 8 plus 5. So we have a half on 0 plus 0 is 0, plus 2 times the sum of the heights is 35. 2 by 35 is 70, and then a half of 70 is 35. So we can estimate that the area of the shape is 35 units squared.